Welcome to my channel. Today we are going to discuss about the space complexity of an algorithm. So say space complexity of an algorithm is nothing but the amount of space that an algorithm requires for its execution is called as a space complexity of an algorithm. So space complexity is nothing but the amount of space of that an algorithm requires for its execution is known as a space complexity of an algorithm. An algorithm which is requires a less amount of space for its execution, then it will be treated as a best algorithm. So best space complexity algorithm. So here in this case the formula for calculating space complexity of an algorithm here is S of p equal to c plus sp, suffix sp. So here s is nothing but space complexity, so p is nothing but a problem. So equals to c is a constant part. So constant means a fixed part or independent part. So constant means a fixed value. So sp is a instant characteristics or dependent part or variable part. So dependent part means if you are taking algorithm, so algorithm is if you are taking array, if you are taking an array, so array is depending on the length of the array. So this is example for variable part. So next example for calculating space complexity of addition of three numbers. So this is an algorithm regarding so calculating regarding sum of three numbers. So sum function performs the addition of a, b and c value. So here a will taking a variable will takes the 1 unit of space, b variable takes the 1 unit of space, c variable takes the 1 unit of space. Totally, so 3 unit of space will be occupied for this algorithm. So our formula is S of p equal to c plus sp. So here c is constant variable, so constant space is 3, and here sp there is no independent dependent variables are there. So that's why dependent variables are 0 here. So here 3 is a constant value. So the constant space complexity can be represented by using O of 1. So in this way the space complexity will be calculated here. So this is regarding space complexity. So it is a constant space complexity function 0 of 1. So next in calculating the another example for space complexity. So assume that so here we have taken one sum array, sum function. So a is an array, n is the value, it indicates the size of an array. So here we have totally 3 variables. So here n is a constant variable, n is a one variable, a is an array, and total is also we have an variable, I is also variable. So n takes 1 unit of space, and total variable takes 1 unit of space, I will take 1 unit of space. So sp means constant dependent variable. So dependent variable means the array variable value. So array variable value depending on the n. So the value of n, assume that the value of n is 5. So here the formula becoming as a 3 is a constant, sp is nothing but so it is an size of an array, so 5 into n. So totally, so here omit the constant values, so n becomes the space complexity of an array. So we can represent the space complexity of an array as a O of n. So O of n is a space complexity of an array. So in this way the space complexity of an array will be calculated. So space complexity of an array is nothing but the amount of space that an algorithm requires for its execution is called as a space complexity. So an algorithm which takes less space for its execution is known as a best okay, best space complexity array. So the formula for calculating space complexity is S of p equal to c plus sp. So here c is a constant variable, sp is a dependent part of a dependent part or variable part. So a variable part or dependent part is nothing but if you are taking array, so array depending on the size of an array. So in this way the space complexity will be calculated. Okay, thank you.